Hello guys, welcome back to our channel. Today we are going to see what is a NOR latch and how it will be performed and how it will be worked and how to make the vanilla code for this NOR latch. NOR latch is nothing but a sequential circuit which is used to store a memory element. In the NOR latch we will use two NOR gates. Here two NOR gates, and we have Q and the Q bar are the outputs, and we have R and the S as the inputs, and other input will be given by the output, will be taken by the output. This is the NOR latch. There is some difference between the memory in ROM and this latch, because in the ROM if we give some data, it will be stored for some time. But in the NOR latch there is a problem that it will be store the data, but if the inputs are changes, then the output will be changed according to the inputs. This is only the drawback in the latch, but we can control this using the clock signal. Later we will see how to control the memory with the clock. In this video we will see how this NOR latch will be worked. Before that, I will write the truth table for the NOR gate. Suppose if we have a 2 input NOR gate, we have 2 inputs. What are the possible combinations? 0 0 0 1 1 0 and the 1 1, right? So if 0 0, both are 0 plus 0 0, so complement will be 1, and this will be the 0 0. So this is the NOR truth table. So based on this we will determine how the NOR latch will be performed. So firstly, in the case 1, let us assume that now R is equal to 1 and S is equal to 0. Then based on that we require the Q and the Q bar. Okay, so now R equal to 1 and S is equal to 0. If R is equal to 1, then what will be the output? If you observe that if one of the input is 1, irrespective of the other input, the output is 0. So what will be the Q? Will be Q equal to 0. So Q equal to 0, and the Q will be given to the other input of the NOR gate. So 0 0. If the both inputs are 0, then the output will be 1. So if you give the input as R equal to 1 and S equal to 0, then the output will be Q equal to 0 and the Q bar equal to 1. Now let apply R equal to 0, S is equal to 0. Now we will verify Q and the Q bar. Okay. Now suppose if we give the, here we got the 1, right? Here if we give the R equal to 0 and S equal to 0, we have the other input which is nothing but the 1. So if we have the inputs as 0 and the 1, the output will be 0. So Q will be 0. And if we have the inputs as 0 0, then the output will be 1. If you observe that if we give the input as a 0 0, it retains the previous state. That means it is storing the previous values. In this way we can say that the latch can be act as a memory element. Now we will verify another case. Now R equal to 0, S is equal to 1. Now we have to verify Q and the Q bar, right? So if we give the R equal to 0, if we give the input S is equal to 1, so irrespective of the other inputs, the output will be 0. So 0 will be given to this one. Here what is the input we have given? R equal to 0. So 0 0, so output will be 1. So Q equal to 1 and the Q bar is equal to 0. Now again I am applying the R equal to 0 and the S is equal to 0. Again the Q and the Q bar will be the same state. Okay. Now we will verify another case. Case 3. Here R equal to 1, S is equal to 1. Now we have to verify Q and the Q bar. Okay. If we give R is equal to 1 and the S is equal to 1, irrespective of the other inputs, the output will be Q equal to 0 and the Q bar will be 0. But what is the actual output will be there? The Q and the Q bar must be complement. But here we are getting the same output, so it will be the invalid state. I am giving as a Q equals 0 and the Q bar 0. And if we give S is equal to 0 and the R equal to 0, in this case the Q and the Q bar will be So if we give s is equal to 0 and s and r equal to 0, and these inputs are both are 0, right? So 0 0 will be, output will be 1. So here you will get the 1 and here you will get the 1. Here also the output is not as the rule. That means the q and the q bar are same, but there must be different. So by this we can write the truth table as r s q q bar. If we have the 0 0 as input, then the previous state will be same. If you have a 0 1, then if you have 0 1, then output will be q will be 1 and the q bar will be 0. And if you have input as a 1 0, then our q will be 0 and the q bar will be 1. And if you have the input as a 1, then the output will be invalid. So this is the NOR latch. Now let me see how to write the Verilog code for this NOR latch. Okay guys, let's start making the Verilog code for the NOR latch. So for that I am creating the module with the name called NOR latch. Simply NOR latch. Here we require inputs, right? Input r comma s, and we require a outputs operation q comma q bar. Okay, here I am closing this. Now I am using the behavioral model. So for that we will use the always at the rate. I am using the asterisk symbol so that any one of the, if any of the input receives a data from the user, then the execution will be started. So always at the rate asterisk to begin. Now for q, what will the operation will be performed? A NOR operation between the R and Q bar, right? So Q bar, and for Q bar, NOR operation with S Q. So these are the operations will be done for the Q and the Q bar. So I am ending the module and module. Now let's write the test bench for this. So module DB register R comma S wire Q comma Q bar. I'm extracting the input from the design code. So nor latch 1. What are the inputs and outputs? R comma S comma Q bar, right? Now I'm giving the initial begin. I'm giving the dump file command so that we will get the waveforms. File.vcd hashtag dumpwares. Now R equal to 1b1 is equal to 1b0 with some delay. Now I will give the R equal to 1b0 and S equal to 1b0. In this, the previous state will be hold. Now I will give the R equal to 1b0 is equal to 1b1 and giving some time delay. And again I will give the some same R equals to B equals so that it will return the previous state. And I will give some invalid all state also. 1b1 is equal to 1 and with some time delay. Okay. Okay, I am finishing the test bench. I'll finish and module. Now I will select the tools and simulator. Now I am going to save this file and I will run this. You have to give the name. I will give the NOR latch. I'm saving this and I'm going to run this file. The file is running. As we have got the output, here you can observe that here r equal to 1 and s equal to 0, then the q is 0 and the q bar is 1, and for r equal to 0 and s equal to 1, here r equal to 0 and s equal to 1, the state q will be high and the q bar will be low. Here the previous state will be stored when the r and the s is equal to the 0, and in this way we have designed the NOR latch using Verilog code. Thank you for watching this video. If you have any doubts, please mention in the comment section. You can get this code in the description. Stay tuned for the next video.